Hello guys, let's do the first video for chemical reactions. This should be pretty quick. It's just an introduction to chemical reactions. We're going to learn what diatomic elements are, and we're going to learn how to write a formula equation from a word equation using skills we learned last unit. So after today, we should be able to name the diatomic elements and write formula equations when the problem gives us a word equation. Okay, so a chemical equation, it just represents a chemical reaction. So this is something you've seen since middle school and maybe even elementary. The reactants are on the left and the products are on the right. So what's being made is going to be on the right or produced. And the arrow just means that to yield. It means to yield something or to make. And this is basically the basic anatomy of the chemical reactions. And yeah. Okay, so there are three main types of chemical reactions, even though we're actually going to learn five, but each of them are a variation of one of these. And then honors, you will actually learn a sixth one after this unit. I would suggest you go ahead and get started on the oxidation reduction reactions and get that out of the way. So yeah, so the chemical reactions here, you have, you are either combining two things, so 1 and 2 will combine to make something new, or something will be broken down into two things or maybe more. So this is more of like two things becoming something different, or something becoming two different things, or two things becoming two different things, if that makes sense. So think of these as chemicals. We're putting two chemicals in and it's going to make a new one. We have a chemical here, it's going to make two different ones. So this is common forms, but we will also have a couple of variations of these as well. So honors in total, you will be learning 6 of them. So chemical equations can be written as word equations or formula equations. So what that means, oh, and the formula equation can be balanced or unbalanced. And in this next slide, I want to show you guys what each of them means. So, for example, the word equation here, that would be like us just telling you what the element is. So, for example, if we mix iron and oxygen together, it will yield iron 3 oxide. The formula equation would be using the element symbol. So for example, instead of the word iron, it would be Fe. And we're going to learn what these symbols mean in a few minutes, actually. But this would indicate that this is a solid, and this would indicate that this was a gas. And then the product over here would actually be a solid that is being yielded. And then balanced would mean, so for example, we had 1 iron over here. If we took that away, we had 1 iron over here, and we had 2 irons over here. So to balance something, you would actually need to add a coefficient, which is in the front. So here we would need 2 irons to balance out this 2 iron. However, it would be difficult to balance the oxygen and the O2 and the O3 here. So we would actually have to put a 3 here and a 2 here. Thus, if we had 2 here, it would be actually 4 iron, so we would have to add a 4 here. And we're going to do problems like this in class to get used to this process. But balance just means that there are the same number of any element on the left side or the reactant side of the equation as there are the product side of the equation. So here are the symbols that you'll see in the equations and what their meanings are. You have solid here, and I'm sorry, the S would indicate that there's a solid. L, as you would guess, would indicate a liquid. G would indicate a gas. AQ, we've learned about ionic bonding and an aqueous solution. To indicate an aqueous solution, for example, if there's a salt in water, that would be indicated with an AQ, and that just means that it's dissolved in water. This double-sided arrow indicates equilibrium, which we actually don't, or reversible reaction, I'm sorry, which we aren't going to use this in this unit. Yeah. I don't recall us using this in this unit. However, in the next, what unit's next? I'm not sure which units are next. I believe we do stoichiometry before we go into like equilibrium and stuff. But we will see this, but not in this unit. We'll see it in a few units past this one. But it just means that the reaction can go back and forth. It's reversible. I'm sorry, you don't see those. So the triangle here, or heat, represents the fact that heat is added. So if we warmed up a solution, that means we need to add this triangle or the heat. And then if you have something above your arrow, that would indicate a catalyst or something that speeds up a reaction. You should have learned that last year in biology when you learned about enzymes. So it's just something that speeds up a reaction. Sometimes reactions will occur, but it would occur too slow for us to observe, so we need to add a catalyst to it. Okay, to change word equations into formula equations, there's this little chart that I like to use. First, you need to decide, is it an element or if it's a compound. So if it's an element, it's going to either be a monatomic element or a diatomic element. And in order for you to determine a monatomic or diatomic, basically, I'm about to show you the list of diatomic elements, and if it's not one of those, it's going to be monatomic. So if it's monatomic, you're just going to write the symbol, and if it's any of these elements here, it's going to be diatomic. If it's any other element on the periodic table other than these 7, I think there's 1, 2, 3, 4, 5, 6, 7, other than these 7, then you will have, then it will just be monatomic. So you would just write the symbol. But again, if it's diatomic, you would write, it would have 2. So that's why oxygen exists with 2. Basically everything in that 17th column is diatomic, and then this one has N and P. So this one is in the 5th one. It's a triple bond between them, and then oxygen will have a double bond in between it. Also, if it's a molecular compound, this is something we learned last unit. Hey. I'm sorry, I had a visitor. But if the substance is a compound, you just have to determine if it's ionic or molecular. So if it is a metal with a nonmetal, it's going to be ionic. We should know this by now. I think we've done it for 3 units in a row. And if it's a I'm sorry, I guess we're going to stick here. But we're going to balance the charges like we did in the last unit, and just come up with its formula. So calcium has a +2 charge, chloride has a -1. So you'll need, you can either do the cross method like I prefer, or you can do the, you'll need another -1 here, and you'll just add them up. However you preferred it in the last unit, you just do it here. So you will have a 1 calcium for every 2 chlorines, and you will have your answer here, and you'll just bring it down. If it's a molecular compound, which means a nonmetal and a nonmetal, also we called it covalent, then you just use those prefixes, the mono, di, tri prefixes. So for example, dinitrogen means N2, tetraoxide would mean O4. So let's do some examples. I would like to just go over it one more time. I'm sorry. So for example, if you are trying to change a word equation into a formula, first you need to determine if it's an element or a compound. If it's an element, it's going to be either monatomic or diatomic. If it's not one of the 7 diatomics, it's going to be monatomic, and then you would just write its symbol. If it's diatomic, you would just have the subscript 2. And if it's an element, you're going to, if it's a compound, you're going to determine if it's ionic or molecular. If it has a metal and a nonmetal, it'll be ionic. If it has 2 nonmetals, it's molecular. And we'll just skip through these because you guys just had a lesson over that. Okay, so for example, on your homework, you're going to be converting word equations, which is this, into a formula equation. So basically, it's just last unit, just a couple of times in each question. So sodium chloride, you're going to write, I like to write the symbol of the element with its charge above it, and then do that little cross method, and then just bring them down like that. To keep it organized and neat, I always make sure that the plus signs and the arrows are brought down directly, because I have noticed some kids in the past might write the arrow a little big or something and completely miss out on a whole element or a compound, and they get the whole problem wrong, and that's always sad to see. So try to keep it nice and organized by bringing down that plus sign. Fluorine is not a compound, it's an element, and it's one of the diatomic elements, so all you have to do is just bring it down here. Bring down the arrow as well. And then this is obviously a compound, sodium fluoride. So it's an ionic compound because sodium is a metal. So you will bring the charges up here. You cross them down, even though they are both 1. So you would just write NaF. Bring the plus side down. And chlorine is a diatomic element as well. Yes, just memorize those 7. There's some acronyms I will kind of show you guys in class. You can make your own acronym out of it, but it is those 7 elements that you will need to have known and memorized for the test. Next question, aluminum is not a diatomic element. It's not one of those 7, so you just bring down its element. And make sure you bring down that plus sign as well. Bring it straight down, I guess is what I'm trying to say. Don't add it here, because then your sulfur will be here, and kids tend to leave out some elements and symbols if they do that. So sulfur is not one of the diatomic elements, and so you just bring that down as well, along with its arrow. Okay, aluminum sulfide is not an element, so we don't have to decide if it's ionic. We don't have to decide if it's monatomic or diatomic. It is a compound. So the compound, we need to decide if it's an ionic compound or covalent. This right here is a ionic compound because of the aluminum. The aluminum is metal, so if there is a metal and a non-metal bonded together, it's going to be considered ionic. So then that's when you put the charges at the top. So I like to bring this 3 down here and the 2 down here, so it would be Al2S3. That's my way of bringing down the formula. So again, keep all of the substances and signs aligned with each other. Otherwise, you'll probably leave out a substance at some point in the testing, and you'll be very sad. Okay, so I'm sorry, I'm getting excited. Zinc sulfide. So we need to determine if it's an element or a compound. It's a compound, right? Because we have zinc and sulfur in here. And zinc is a metal, so it's an ionic compound. So you just bring the charges above it. So zinc has a +2 charge, and sulfide has a -2 charge. So you just bring the charges down and across, and it'll be ZnS. Be sure to bring the plus signs down, kind of straight down, so that they're not like right next to it. Magnesium arsenate. Magnesium is a metal. So this compound here is going to be considered ionic, and so we do the whole charges up here. Arsenate is one of the polyatomic ions, so we just grab that off the sheet, and we're going to cross these down, and it will become Mg3 ASO4 2. Bring your arrow down. And zinc, these are both ionic compounds because they start with a metal. You'll get to where you'll notice that this is a double replacement, and you'll know that the metals are just going to replace each other, or the non-metals, whatever. So anyways, bring that down. Do your cross, bring the, what is this, superscript, and bring it down, and you will have your ionic compound. And then you just do the same for the last one.